It is not 0, it is sometimes 0, but for odd numbers 1 pi means -1, -1 is positive value, d square by d square is not equal to 0, is not always equal to 0. That means there is a point of inflection. So at x equal to, hence point of inflection will lie because third derivative is not 0. The second derivative we have equal to 0. This we put the condition that if second derivative is 0, then third derivative must not be equal to 0. Then there will be point of inflection. Here point of inflection lies, x is the point of inflection. So this point also, this curve also meets the axis of x, because we have proved that this for y equal to 0, this is also giving us an x equal to n pi. Hence at x equal to a n pi, the curve crosses the y-axis. The curve, crosses the axis of x, crosses the axis of x, and also points of inflection lies. Points of inflection also lies, are also there or also lies. Points of inflection also lie on the given curve. Why? Because as when d square by upon dx square equal to 0, this implies that dq y upon dx cube is not equal to 0. This we have proved here. It means point of inflection are lying. Okay, there are points of inflection upon this curve. Okay, question number 2 we have done. Now let me talk about question number 3. Okay, what does question number 3 say? Let me check it. Okay, now question number 3. Let me check it. Equal to this. Okay, so question 3 is, show that the points of inflection of the curve this lie on the line this. Okay, if they are lying on this line, points of inflection of the curve this lie on this line, 3x plus a equal to 4b. That we have to prove here. Okay, so let me check it. Question number 3 here. But the curve here is y square is equal to x minus a whole square into x minus b. Okay, lying on the line this, the points of inflection of this. So double derivative we have to find out, but before that let me take y is equal to how much? This is plus minus x minus a under root x minus b. Okay. Y equal to plus this value minus this value. The two values of this we will calculate, but before that let me find out differentiating this now. Differentiating with respect to x. Differentiating it with respect to x, we get this is dy dx is equal to, by product rule we have to multiply, we have to solve it. By product rule, if I solve it, this is, first let me put here this under root x minus a. Let me first differentiate this by product rule only. So this is nothing but under root x minus b as it is, into x is 1, so this is plus minus here, again plus minus. Now this is to be differentiated. This is 1 upon 2 into x minus b whole minus half into x minus a as it is. Try to understand. So what does it give us? It will give us x minus b half is the root of this into multiplying this, because x minus b LCM taking, it will be x minus b only. Plus minus sign is out, and here also let me take plus sign. This is so 1.2 is twice of this x. This is 1.2 here. Okay, 2 will come here. All right. Twice x minus b. Plus this is x minus a only. Why? Because this x minus b whole power minus half we have taken. This is has come in the denominator. This is twice of this. So in the numerator we get twice x minus twice b. This is plus x minus a divided by twice into x minus b whole power half. The d by dx here. Now let me solve it in the numerator. Twice x. Okay, plus x. This is 3x. Is it plus x here? Okay, no minus sign but plus sign. X minus b, x minus a. This is 3x minus twice b minus a divided by 2 into x minus b whole half square root. Now again differentiating it again will give us second derivative. This is d square y upon dx square is equal to this value. So numerator, this is twice into under root x minus b as it is. Differentiation of this will give us 3 only. 3x is differentiated. Minus sign now 3x minus twice b minus a as it is. Differentiation of this. Differentiation of this will give us again 1.2 and this was here 2 upon 2. 1.2 here power is x minus b whole power minus half divided by this is x minus twice into x minus b whole square means half cancel out, only power. Now this half power will come again. So what will it give us? It will give us as okay, this 2 will cancel out. So this is twice into x 3 2 just 6. I'm sorry. This is 6 into x minus b, because this half power x minus b will come in here in the this x minus b, it will be 6 into x minus b. This is the minus sign 3x minus 2b minus a only divided by now this power will come here twice into x minus b whole power 3 by 2 because this is 1 and a half power. So it will give us 0. Alright, so this is 0. Now first let me solve the numerator. It will be 6x minus 6b minus 3x minus plus 2b plus a divided by twice into x minus b whole power 3 by 2. Now if numerator is 6x minus 3x means 3x only, and so minus 4 6b plus 2b means 4b plus a divided by twice into x minus b whole power 3 by 2. Now if I put dx this value, and then we see here that this is the equation 3x minus 4b, so 3x plus a equal to 4b. Yeah, so this will give us the equation. Now if I find out this value, the triple, okay, let me first solve it. So d square by upon dx square upon dx square equal to 0. This was the value. D square by upon dx square. This we have just calculated. Equal to 0 implies that this is 3x minus 4b plus a equal to 0. Okay, or 3x plus a is equal to 4b. So this is that straight line. Now we know that for this value, if I find out value of x from this, it will be 4b minus a. If I substitute this in this equation, in triple derivative of this, then again this will not be 0. So we can prove we can prove that at x equal to 4b minus a upon 3 dq by upon dx cube is not equal to 0. If I find out triple derivative, we know that this is x value in terms of b and a. So if I substitute here, this will not be 0. Now, I mean, again, after differentiation, next time, that means triple derivative, we have to find out this is not equal to 0. At this point, x equal to this. So it will not be 0. That means this is the straight line at which the point of inflection lies. So the point of inflection, of the curve, this one lie on the line this. Okay, this is the proof here. Hence, the points of inflection are lying on this line. Solving this line, we will find out x equal to this value. Hence, d square by dq by upon dx cube will not be 0. That means the straight line this will give us the inflection points. Hence the points of inflection. Hence the points of inflection will lie on this line, because only from this line we can find out the points x equal to this. Then solving this y can be calculated. The values of y will be these two values, x substitute here, two values of points. So those points of inflection will lie on this straight line only, because from this straight line only we can find out the values. Okay, so hence the points of inflection will lie on the line, on the straight line. This is the straight line here. On the straight line, the equation of the straight line, 3x plus a is equal to 4b. Hence proved, this proved. This we have to prove here, hence proved. This is done. Question number 3 we have proved that 3x plus a equal to 4b is the straight line on which the point of inflection will lie. Okay, so this is question number. Now, question number 3 we have done. Now let me talk about question number 4. Okay, now question number 4 is of what kind? Just to find the point of inflection, we find double derivative that is equal to 0, and then we prove that triple derivative is not equal to 0 at that point. Okay, so then there will be point of inflection. This we have proved from concavity and convexity of the curve. Okay, now 4th point. Find the points of inflection on the curve this. Okay, let me find out. So points of inflection in the curve. Question number 4 here. So curve is here. Curve is a square plus x square into y is equal to a square into s. Okay, or y is equal to, we can find out a square x upon a square plus x square. Now let me find out double derivative, then equating 0. So that's solution here. So differentiating this with respect to x, we get, what do we get here? D by dx, differentiating it by quotient rule again. So this function a square plus x square as it is, differential this is only a square minus sign. Now a square x as it is, differential of a square plus x is twice x divided by this is a square plus x square whole square. Okay, now let me solve the numerator. It will give us, okay, if I take a square common, it will give us a square plus x square minus sign. This is twice x square divided by a square plus x square whole square. We are left with 1 x square cancelled out. In the numerator we are having a square minus x square divided by a square plus x square whole square. Again differentiating it, got the second derivative. we have to find out. For the second derivative, let me find out this d by dx here. Now d square by upon dx square is equal to, now this is a square plus x square whole square as it is. Differential of this value will be minus twice x into a square. It will be a square into minus twice x. Differentiation of minus x square. This value is, let me take minus sign here. Now a square into a square minus x square as it is. Okay, into differential of this will give us twice into a square plus x square into twice x multiplication. Twice x divided by a square x square whole square. Sorry, whole 4 now. I'm sorry, this is whole 4 now. So this is the next value. So let me further solve it. Now anything common here, a square, okay, plus x square is common. And twice x is, this twice x is also common. So twice x into a square plus x square, let me take common. So from this is minus sign. This is minus sign a square. This one a square is also common. Let me take a square also common outside. This is into a square we have taken outside. This a square will also come as common. So now from first to minus sign and this value, a square plus x square will remain as a remainder. Now from second part, we are having 2x we have taken no problem, but this 1, 2 will be there. And this a square plus x square we have taken outside, a square also taken twice into, this is with minus sign here in between, twice into a square minus x square is the remainder. Is it a square x square whole 4? Now what the value? X equal to 0, the first axis, x equal to 0, first point is. From this a square x square is not giving us real numbers because x square equal to minus a square, which is not giving us real number. But this x square is here. And the left part, let me first solve it. Then we will find out. So this part is, this is twice a square into x within bracket a square plus x square. Okay, and this is the second part is minus a square minus x square. This is minus twice a square, yeah, and plus x square, plus 2x, sorry, this is 2 minus plus x square. What do we obtain here? This is a x square positive minus 3a square, alright, divided by a square plus x square whole 4. Now, so finally we obtain this value as twice a square into x into a square plus x square. This is bracket. This is x square minus 3a square. This value minus 2a square minus a square minus 3a square, and twice x square minus x square is x square only, divided by a square plus x square whole 4. Now if this is equal to 0, okay, so if I find out this triple derivative, that can also be done. Okay, triple derivative must not be equal to 0, will not be 0, but let me first solve it. So this will give us, that is x equal to 0, this x equal to 0. This is not possible because a will be non-real number, and from this the value will be there. So x will be and plus minus a root 3. X equal to, from this, a root 3 but plus minus sign. So there are 3 points here. So what is the value of y then? And for that y is equal to 0 something upon 0 is 0, so y is 0. First point is 0, 0 from first equation. So from first equation, y equal to 0 at x equal to 0. This is the first point. If I put here 0, 0 point something 0, so y equal to 0 at x equal to 0. Now if I put a under root 3 in place of x, that will give us, and y is equal to a square into a under root 3. That means a root 3. That means aq upon 3, aq root 3. A square was already there, and this is a under root 3. aq root 3 divided by this value. This is a square plus a square root 3. A square 3a square. Sorry, it's 3a square because x is here a root 3. This one. A root 3 means 3a square. Squaring this value, so it will give us 4a square in the denominator. This is aq root 3 upon 4a square. That means a root 3 upon 4. A root 3 upon 4. This is one value. Second value is, what is the points here? We are solving points of inflection. Oh, sorry. So points of inflection was, this was twice a square into x into a square plus x square. That was there. Oh, sorry. The points are okay. Those points are already calculated, no problem. So we are finding out the points here. So we have to substitute here in this case. So first point was 0, 0. At second point, a root 3 positive. Y is calculated as a root 3 upon 4. And at second point, minus a root 3. What is the value of y? That can be calculated from this. So these points, the third point is y is equal to a square. Again, even if it is negative, it will be negative sign in the numerator. So it is aq 3aq, sorry, a root 3. aq root 3 minus sign, because x is minus a root 3 divided by, this is a square plus again a square root 3. A square 3a square, sorry. This is positive only because x square is positive. It will give us minus sign root 3a upon 4. This is the only difference. The second point is, third point is this minus root 3a upon 4. So these are 3 points here. Points of inflection we have to find out. Find the points of inflection of the curve. This. These are 3 points here, 0, 0, a root 3 and a root 3 upon 4, and minus a root 3, and undoubtedly we know that. And if we differentiate that d square by dx square again, dq y upon dx cube will not be equal to 0. So there was here in the denominator a square plus x square whole 4, then that will be whole 8, power will be 8 here. Numerator will also come there. So at this point, these points, the value of dq by upon dx cube will not be 0. That is also, hence these are the points. Hence 0, 0, a root 3 by 4, and minus a root 3 and minus a root 3 upon 4 are the points of inflection. Okay, these are the points of inflection. We have to just find out point of inflection with the help of double derivative equal to 0, and then substitute the value of that x in the given equation. We will calculate that value. That is how the solution is. Okay, so now let me take question number 5 now. What is question number 5 say? Let me check it. The question number 5. Question number 5 here. Okay, so question number 5 says show that the points of inflection on the curve with this. Okay, the curve here is polar curve. R is equal to, this is theta into, with that B into theta raised power n. Okay, are the given by this. Okay, so that the points of inflection on the curve with this are given by, to show that points of inflection are given by R is equal to, the radius is equal to B into minus sign, this is minus n into n plus 1 whole power n by 2. Okay, so this they have to prove here. First of all, we have to find out dr upon d theta. Solution. So differentiating the equation number 1, this is the equation of the curve. Differentiating first with respect to theta. So differentiating first with respect to theta here, we get dr d theta is equal to, it will be n into b into theta raised power n minus 1. Okay, again derivative, again differentiating it, we get, what do we get? This is d square r upon d theta square is equal to, this will be n into n minus 1 into b into theta raised power n minus 2. Okay, this is value of d square r upon dr square. Now we know that at polar coordinates here, polar curve, sorry. So what the polar curve, we know that this is r square plus twice into dr upon d theta whole square minus r into d square r upon d theta square equal to 0. This is for polar coordinates. For polar curve, this must be equal to 0 because rho is 0. Rho is infinite, so this value must be 0. The denominator must be equal to 0. This we have already proved that for polar curves, this value, which is r square plus twice into dr upon d theta whole square minus r into this value must be 0. Now let us substitute these values in the given equation, because d square r upon d theta is equal to this value. This we have to substitute here. R is that value given. Okay, so let me solve that value. So this will give us r square. R square means this is square. It is nothing but only n power. Sorry, this is r, I'm sorry. So r square is b square into theta raised power twice n. Okay, plus 2 into dr d theta. Dr d theta is this whole square. It will be whole square of this. That means n square it will be into b square into theta raised power twice n minus 2 whole square. Okay, and then minus sign r. R is b into theta raised power n. This is the value of r here. Substitute here r. And then d square r upon d theta square is this value. This is n into n minus 1 into b means b square. B is already there. B square it will be with theta raised power n minus 2 and theta n. It will be theta raised power n 2n minus 2. Let me write here theta. Or let me write theta is equal to n minus 2, theta raised power n minus 2. This is value of this. Now let me further solve it. Then equating that 0, that will give us the final value. It will be b square theta raised power twice n plus twice into n square into b square into theta raised power twice n minus 2 minus sign. This is b square theta raised power, I'm sorry, first let me write n into n minus 1. It will be n into n minus 1 into b square, yeah, into theta raised power twice n minus 2 equal to 0. So this is equal to 0. So if I take something common from this, what it will be. Okay, so this is the fifth question. So R is equal to this we have to prove. So what is the value of R? R is this. So from this we have to find out value of theta or something. If I take B raised power twice and common, okay, you have twice and minus 2 common. Let me take B square. It is B square common throughout. B square common. Okay, and then B square is common. Theta is 4. Let me take twice and minus 2 common. Twice and this is minus twice and we divide it, so theta square will be there then. So it will give us 2 is not common. Okay, so it will give us theta is for twice and minus 1 and okay, so this is theta square here. For twice and minus 2 we are taking common, but here it is minus 2, 1 upon minus 2 will be there, so it will come in the numerator. Okay, so this here plus twice n square, this is twice n square, okay, plus minus sign, this is n into n minus 1 only equal to 0. It is giving us theta equal to 0. First is theta from this 0, and second point is this one. So second part is and theta square, for this is twice n square minus n square and minus n plus n, this is minus n square, and so we are having here theta square plus n square plus n equal to 0. So here theta is equal to, okay, so theta is equal to, theta square is equal to, this is minus sign common from both sides, and common it will be n plus 1 then. Both are negative, and that side minus sign we have taken, so n square, and common also we have taken, so n plus 1. Okay, so theta equal to minus plus minus this value. Okay, so this is theta whole square, so half of this value, negative value. So theta is equal to from this minus n into n plus 1 whole power half. If I substitute this value theta here, okay, so R is equal to then this value. So substituting this value of theta in first, substituting this value of theta in